Hi, today I come up with a new topic that is troubleshooting in BGP convergence delays in multi-cloud PaloAlto SD-WAN deployments, optimizing network performance across complex cloud environments. Please try to subscribe to share interesting coming videos. Introduction and context. Troubleshooting BGP convergence delays. BGP convergence defined. BGP convergence is the time routers take to reach stable routing state after network changes like failures or updates. Impact on enterprise network. Slow BGP convergence affects application availability, causes packet loss, session resets, and extended outages during failovers. Complexities in SD-WAN cloud. Convergence delays arise from SD-WAN overlays, IPsec tunnel health, cloud routing, and policy recalculations beyond traditional BGP timers. Systematic troubleshooting approach, analyzing protocol behavior, control plane interaction, and cloud constraints helps avoid isolated symptoms fixes for convergence delays. Agenda and learning objectives. Fundamental concepts. Overview of BGP convergence and its importance in SD-WAN multi-cloud deployments. References architecture. Introduction to the SD-WAN architectures across AWS, Azure, and Google Cloud with BGP integrations. Troubleshooting symptoms. Common symptoms of convergence delays like slow failover and asymmetric routing. Optimization and best practices. Guidances on reducing convergence delays through design and tuning recommendations. BGP and SD-WAN architecture. BGP convergence overview. Phases of BGP convergence. BGP convergence involves failure detection, route update, propagation, best path calculations, and forwarding table installation until stabilization. Traditional WAN convergence factors. In traditional WANs, convergence times depends on timers like keep alive and hold minimum route advertisements interval and routing table size. SD-WAN enhanced convergence. SD-WAN integrates BGP with continuous path monitoring, triggering routing changes due to latency, jitter, and packet loss brownouts. Optimizing convergence. Understanding delays in failure detection, route propagation, and policy recalculation helps or optimize BGP convergence effectively. Palo Alto SD-WAN in multi-cloud deployments. Secure multi-cloud connectivity. SD-WAN fabric interconnects branches, data centers, and clouds via secure IPsec tunnels for optimized access. Dual layer routing model. BGP overlay exchanges routes while SD-WAN overlay monitors the path health and enforces routing policies. Failover and convergence challenges. Network events can trigger multi-layer changes causing convergence delays and complex troubleshooting scenarios. Cloud SD-WAN apps deployment. Prisma SD-WAN apps deploy in public clouds like AWS, Azure, and GCP for regional aggregation and cloud workload access. Symptoms and root causes. Typical convergence delay systems. Slow failover effects. Slow failover causes a traffic to remain on degraded paths to leading to packet loss and increased latency. Prolonged route withdrawal. Obsolete routes stay in routing table after tunnel or peer failure, delaying convergence. Asymmetric routing issues. Uneven convergence causes stateful firewall drops and session instability in connections. Cloud route updates delays. Delays between BGP changes and cloud route table updates impact multi-cloud SD-WAN performance. Common root causes of delayed convergence. Timer mismatches. BGP keep alive and old timer differences cause slower failover detection and delayed convergence in SD-WAN deployment. Excessive prefix advertisements, large routing tables with many Prefixes increase processing time, causing slower BGP convergence during mass route changes. Path hunting and route churn, multiple path evaluations, and aggressive brownout detection lead to frequent path changes, destabilizing routing convergence. IPsec tunnel and cloud delays. Delay in IPsec tunnel re-establishment and cloud provider propagation cause unavoidable timing gap during convergence. Troubleshooting and optimization. Structured troubleshooting workflow. Establish baseline metrics. Begin troubleshooting by defining unexpected failure timers and normal BGP behavior under controlled conditions. Verify BGP neighbor states. Check BGP neighbor states to identify delays during session teardown, re-establishment, or route exchange. Analyze BGP attributes. Inspects AS path, local preferences, and MED MED to understand path preferences or delays. Correlate SD-WAN events. Match BGP findings with SD-WAN events such as path down, brownout detection, and policy recalculation. Review logs and cloud validation. Examine logs and cloud side resources like route tables and gateway health for updates and anomalies. Optimizes best practices. Balanced BGP timer tuning. Careful tuning of BGP timers ensure consistency and prevent session flaps in SD-WAN multi-cloud networks. Route summarization benefits using route summarization reduce prefix count and processing overhead during convergence events. Enhanced failure detection and with BFD. Bidirectional forwarding detection accelerates failures detection, improving network resilience over standard timers. Incremental changes and testing. Incremental configuration changes with regular failover testing ensures real world convergence performance and improvements. Design guidance and conclusion. Design recommendations for faster convergence. Regional SD-WAN hubs. Using regional SD-WAN hubs minimizes latency and limits failure impact across geographies. Active-active architecture. Active-active designs enable smoother traffic shifts and faster reconvergence than passive setups. Stable addressing policies maintain stable addressing and advertisement policies reduces prefix churn and keeps convergence predictable. Built-in observability. Incorporating logging, telemetry, and monitoring from the start helps quickly detect and analyze convergence issues. Summary and key takeaways. Complex causes BGP delays. Delays arise from interactions among routing protocols, SD-WAN control plane, IPsec tunnels, and cloud constraints. Importance of understanding interactions, grasping these interactions in is crucial for effective troubleshooting and optimizing BGP convergence in multi-cloud environments. Methodical approach benefits using protocol fundamentals, structured workflows, and cloud knowledge helps reduce failover times and maintain stability. Good design and validations, combining design best practices, tuning, and validation ensures resilient and high performing hybrid and multi cloud connectivity. This is the last slide for today's session. Thank you.